Hi everyone, geophysicist Stefan Burns here. We have a special report to do tonight talking about weather manipulation or weather modification. Just in general, weather here on this planet, the direction it's going, this is intimately linked to climate, and also whether we have an impact on this. And one of the reasons I'm covering this topic today, as I've covered many times on this channel in the past, as longtime viewers would know, is because there was just a devastating flash flood in Texas. This was on July 4th. There was over 26 feet of rise in the Guadalupe River in about 45 minutes. In over a 2-hour time frame, actually just less than 2 hours, the Guadalupe River rose 35 feet. And so there was at 4 a.m. in the morning in hill country in Texas, from the remnants of Tropical Storm Barry, there was 10 inches of rain that happened in 1 hour. And so, of course, this is what leads to a flash flood. It's not like the Earth has never had flash floods before, but because this happened in the United States and happened on Independence Day, it's getting a lot of attention. And now there has been a new push to examine weather manipulation or weather modification and to make that a felony. So we're going to talk about that in today's video, but we're going to go beyond what you'll normally hear about, because most people point the finger at one thing or two things. They don't actually address all the things that modify our weather. So we're going to go into all the ones I know of. I can't cover all of them exhaustively in this live stream, but I will do my best to lay out a framework of understanding and basically like key information and highlights, so then you can go from there and do your own research. But we really want to get that holistic, zoomed out view, or else you're not going to be fully informed. And that's what people want you to be. They want you to be divided, and they don't want you to be fully informed, knowledgeable, aware, and on top of it, and asking questions and demanding answers. So this is a whole circus here. Don't think that I'm endorsing this or anything, but we just had Representative Marjorie Taylor Greene introduce a bill prohibiting the injection, release, dispersion of chemicals or substances into the atmosphere for the express purpose of altering weather, temperature, climate, or sunlight intensity. And she wants with this bill to make it a felony offense. She's been researching into this for a few months, and now with this, she's riding that wave. This is zero endorsement of this on either side. I'm just showing that now the political circus is interested finally in talking about weather modification. Though those of us that have been researching into this for a while will know that this has been going on for a long time. I read a book a few years ago called Earth's Aura. And this was talking about the early weather modification experiments that were occurring in the 20s, the 30s, the 50s. For example, shooting a rocket up into a storm system packed with silver iodide and seeing what happens. Also, all the nuclear testing that we did from the 40s, 50s, 60s, 70s, 80s, 90s, all that is weather and water modification, because there's a massive release of energy, explosion, plasma. You create global effects as a result of the neutron decay from that explosion, and there's a whole bunch of geophysical effects. Well, the Earth is one large geophysical energy circuit called the global electric circuit. And so when you do those sort of things, you're modifying things quite significantly. But this storm here that hit Texas was really, really remarkable. I mean, historic, effectively. 10 inches of rain, again, in an hour at around 4 a.m. This is 4th of July weekend, so you got to think about it. You have a bunch of people going down to the Guadalupe River. It's been hot, hot, hot. They're celebrating 4th of July. They're setting up camp. There's, camps for scouts, and there's I think there's 20 girls still missing from Camp Mystic. I don't know all the details. There's so much that happened, but hundreds of people are missing from this, and very likely hundreds of lives lost as a result. But people camping along the river, and then at 4 a.m. it rising up super quickly. Also, people that are living in trailers Those just got swept away, again, 26 feet in 45 minutes. Let's look at that sea level rise by the USGS. But before that, this is the storm system. So this is a tropical storm that came in off the Gulf of Mexico, Gulf of America, just the Gulf, went into Texas and then kind of stalled out and stayed in place. Look at it, it's basically just moving around hill country. We see Austin there, San Antonio there, just stayed there. And hill country has some topography to it. So it's going to take this water and basically guide it towards certain areas, low-lying areas, natural waterways, and therefore you can get this really big increase in the height of water very quickly as you have this discharge hit main riverways like the Guadalupe River. So that's some of the just understanding there. And I've been standing over the photo here of the Guadalupe River. Once it was daytime, you see just how high up it is. There were people that were climbed up in trees and were holding onto trees. Some people were even riding the river like in the tree because the trees got swept away and they're up in the top branches hoping the thing doesn't tip over. Like there's some absolutely insane experiences that were had and stories that you can find, and also heroism, acts of heroism by a variety of people saving the lives of loved ones, family, and friends. So really on July 4th, a very powerful moment. So, you know, rest in peace to everyone that was lost in this incident, and prayers for everyone that was affected and injured, and hopefully everyone does well afterwards. But let's look at the USGS river data, because this is quite fascinating. This is just, again, like the most kind of notable thing that's happened as it relates to weather recently in the U.S. We're going to get into that weather modification, because as the weather becomes more severe, bigger, stronger, faster, we're going to see things like this more often. So it's good to understand a case study like this. Another case study would be March, April, and May of this year, when we had crazy tornadoes going across the U.S., one of the most active tornado seasons in a very long time. And that's also connected to the space weather that we were having, because space weather and solar activity affect our terrestrial weather and even things like earthquakes. But that's not the point of today's video. So here we have 7 days of data here for the Guadalupe River. This is near Kerrville, Texas, and this is basically normal changes to the river here, and they all just got compressed down to a solid line, basically because of this massive spike due to the flash flood. So here we have the time, and that is registering at 5 a.m. July 4th. Here is what it's saying at basically 12 a.m. right there. So an increase in the height going from 0.4 feet, let's say, up to 1.75. And then from 5 a.m., we go right there to 6:45. Now it's 34.29 feet. So that's absolutely insane. You now see how it's been discharging. It's still quite elevated, but it's at about 3.15 right now. Here's the number there. But a massive, massive push of water down the Guadalupe River because of this storm system that was hanging out in hill country, dumping a tremendous amount of water over 24 hours, not really moving. And so a lot of people are looking at this, wondering, okay, was this the result of weather modification? And so the next thing we'll go into is that we already have the government talking about weather modification. It's not like this is some secret covert thing. It very well could be. That there could be large-scale covert weather modification experiments going on. There's so much conflicting information out there on weather modification that it's kind of difficult to get a sense of what is truly happening. And because it's like it's all over the place. It's in the conspiracy land. And so it's really hard to filter out the truth from all the false and fake conspiracy theories, which makes it difficult. And so I'm not saying none of these conspiracy theories are actually the truth, but I'm saying that we don't even need to go there to see that there is weather and climate modification occurring. And NOAA has a page, the Weather Modification Project Report page, where you're supposed to disclose any weather modification projects that you're doing. And so you can scroll down here NOAA collects this information. Activities subject to reporting. You can read it right here. I'll link this in the video description after the live stream's over. But just for example, seeding or dispersing of any substance into clouds or fogs to alter drop size distribution, produce ice crystals, coagulation of droplets, alter the development of hail or lightning, or influence in any way the natural development cycle of clouds or their environment. Then there's like using fires or heat sources to influence convective circulation or to evaporate fog, modifying solar radiation exchange of the earth or the clouds through the release of gases, dust, liquids, or aerosols into the atmosphere. But there's a whole bunch of things, and some of them aren't like that significant, but they are technically weather modification. But like, for example, using aircraft propeller, downwash, jet wash, or other sources of artificial wind generation, like that's probably not something that covert secret groups are doing. But it is technically weather modification. Look, read number 8 right here. Using lasers or other sources of electromagnetic radiation. So that's something that also has been done. That's, you know, all these things exist. The technology is there. Again, we've been doing this since the 20s and the 30s in a very conscious way. We've been modifying the weather through human activity basically since the beginning. We're going to talk about that because that's a very important component of weather modification. But in terms of very intentionally trying to steer and change natural weather systems, that's been going on since the 20s and 30s with the initial experiments, and then really ramped up in the 60s and 70s, and we're in 2025 right now. So you can go all the way down, and they have these reports here, and so I'm just going to set it to show 100 entries, and they're from all across the US, and you can click on them. Here's one from the California area, and it discusses what they're doing. So this one specifically, I would have to actually read through this one. A lot of them are talking about silver iodine flares. So they're releasing silver iodine into these cloud systems in an attempt to modify them. And if I click, I mean, just some of these ones at the beginning here were like that. So let's just click this one and see what it says. But here's anti-hail devices that will be activated when a potential hailstorm is approaching. And within this cone, hail is broken by captivation. Hail growth is suppressed by ionization. So there's a whole bunch of small scale experiments too. Like they're really small in scale, but technically they're weather modification, so they have to release a port. But there are some of these experiments which are larger. You can look through them and be like, we launched flares into a storm that had silver iodide to cause these sort of changes. So for people that are really, look at this though, 1,098 entries. So you're going to have to go take some time to go through this to get a sense of the scale, the normal scale and scope of these weather modification experiments. But they are quite intense. But let us go into just in general the truth of weather modification, because it's not just like some secret covert group. It's happening right now. It's been happening for decades of years, and each and every single one of us is a part of it. So before that though, I do want to show you this photo here. I showed it on the last live stream, and this is a gigantic jet. Basically a massive plasma discharge from a thunderstorm, and this was actually right near Mexico and Texas on July 3rd. And so this was almost certainly from that tropical storm Barry, the remnants of it, and we see this massive discharge of plasma going up to the ionosphere. And so this very nicely shows a connection between these sort of weather systems and this tropospheric activity, the accumulation of charge here, and how that can actually cause a massive plasma discharge. This was less than a second. So this is the best photo you've ever had of a gigantic jet captured from the International Space Station from astronaut Nicole Ayers, early morning for Texas on the 3rd. And this is just showing that larger flow of energy across the globe. So if we're talking about weather modification, that's really what we need to be discussing. So let us talk about our global electric circuit so you get a better sense of just what the heck is actually happening. This is a very simplified graphic here and model here, okay? So this is very simple, and you can already see it looks quite complex. So keep that in mind. Our understanding of these systems is quite limited compared to the reality of the situation, and therefore that's why I think these weather modification experiments are really stupid, because we don't really exactly know how we're perturbing the system and what the end result is going to be. I think it's incredibly dumb. Everyone has their own opinion, but as a geophysicist who respects nature and thinks that just letting nature do her thing is probably the best policy, anything that disturbs this, I think, is going to have a lot of unintended consequences and effectively be like opening up Pandora's box. And we're already doing it. But we see here our ionosphere. This is the uppermost part of the atmosphere, about 50 kilometers up on the daytime side of the Earth, more like 100 kilometers up, and then above that, on the nighttime side, it decharges at night. It's about 1% plasma. And plasma is that fourth state of matter where you have electrons actually being stripped off of a molecule, or for example, even just like a hydrogen ion, or just a hydrogen, right? So you have the hydrogen, the electron, the proton, then you create this hydrogen ion and electron, things like that. So now you have these charge carriers. They can flow, they can create electric currents, and during something like a space weather impact, which we're actually under right now, we're having the solar wind be fairly strong and giving us elevated geomagnetic activity. The ionosphere gets more charge from outer space. There's more plasma, stronger electric currents. That drives a stronger global electric circuit. And there's connections between space weather and tropospheric weather, or like weather down here that we experience. And there's certain types of space weather that really lead to these enhancements of terrestrial weather, specifically coronal hole high-speed stream impacts, which is actually what we have coming up effectively right now. But that is not outside the scope of this video, but not the main purpose of today's video. So here we have a thunderstorm. We see the charge differential in the thunderstorm. We see that it causes precipitation, lightning discharges, sometimes point discharge currents. You can have intercloud lightning strikes. You also can have these transient luminous like events going up, or like, for example, that gigantic jet or sprites. A whole bunch of these plasma phenomenon can launch from the top of a thunderstorm up to the ionosphere. Most of the resistance in between the ground surface and the ionosphere is in the boundary layer, the top 2 kilometers, or let's just say like 1.6 miles, something like that, okay? 2 miles is where most of the resistance is. And then once you get above that, or especially like once you're like 5-10 kilometers up, the conductivity actually increases quite a bit. Because the air in between the ionosphere and the surface is very resistive. It does not allow a flow of electric charge, but the surface is quite conductive. That has a conductivity of about 10 to the negative Siemens, S-E-I-M-E-N-S. That's the unit. And then also the ionosphere is also about 10 to the negative Siemens. But the atmosphere in between is 10 to the 14, like 10 to the negative 14. So 7 orders of magnitude difference. And metal is very conductive. That's going to be important when we're going to talk about metal in the atmosphere, specifically like the stratosphere, how that could be affecting things. But what researchers that look into the global electric circuit have effectively identified is that the research indicates and the data indicates that the most important driver and aspect of the global electric circuit is the conductivity of the atmosphere. So when the conductivity changes, the global electric circuit changes. What is a circuit? It's a flow of energy, and you don't have a circuit unless you have a flow of energy through all parts. And so the rate of the current in that circuit will be determined by the most resistive part. And so if this all of a sudden becomes more conductive, there's going to be a lot more energy flow through that circuit. And well, a thundercloud here, for example, can be 50, 100 megavolts. The ionosphere, for reference, is 250,000 volts. So, or 250 kV. This can be 100 MV. Huge difference. And then the atmosphere itself generally is neutral. And same with the ground surface. It's basically neutral in its charge. So that builds this charge differential. Because you have a voltage differential, that forms that fair weather current. During fair weather conditions where you don't have any of this stuff, you have a simple current going like this and linking the two together. Slowly, slowly, slowly equalizing them together. But you have all these things occurring, sunlight hitting the ionosphere, space weather effects that in general keep that charge of the ionosphere stable. It's an equipotential, typically about 250 kV. during a space weather impact, it can be 350, 400 or greater, especially in the polar cusp region in the high latitude zones near the North Pole, South Pole. And then the surface stays in general negative or neutrally charged. But when you put this cloud, which has a massive electromagnetic potential to it, move it through this very resistive soup of the atmosphere, it creates really strong electric currents. That's why you get these transient events going up, like for example, that gigantic jet that can then link the two instantly together. That creates a very strong electric conductivity profile, basically electric current in between the two, and these are all electrified. So when you start altering the larger global electric circuit of the planet and increase that current flow, these things are going to get stronger. That's the bigger perspective that we need to start with right from the get-go. Is A, what's happening to the global electric circuit on this planet? Is it getting stronger? Is it getting weaker? Is it not changing? And if it is changing, and hint, hint, it's getting stronger, what is making it stronger? Why is Earth undergoing this electrification process? I call this Earth electrification. It's basically the process that we're in right now at this moment in time. But there's a whole bunch of other things you see that affect the global electric circuit. You have these very high, like stratiform clouds. You have natural radioactivity creating ions. You have galactic cosmic rays coming in creating ions. Even corona discharges from like high power transmission lines, and you have point discharge currents, and just a whole bunch of stuff. Solar energetic particles, relativistic electrons. It's a very, very active system, and there's a lot more we need to learn about it, okay? So that is the global electric circuit. If we're going to talk about weather modification, we need to talk about the global electric circuit first and foremost. That's probably the first thing that you'll realize no one is telling you if they're talking about weather modification other than a very few people. And next, let's talk about our larger environment as it relates to solar activity. Here we have, because the sun is the big driver of climate. If we turn the sun off, we have a master switch for God, we turn it off. Well, I've said this so many times, but it bears repeating. The earth becomes cold, dark, and lifeless. So the sun is the main driver of everything. Everything else is modifying that solar energy input. Now, going from solar minimum to maximum, we see here that data. This is total solar irradiance. You basically calculate all the energy from the light spectrum of the sun and measure it as watts per meter squared hitting the earth. That only varies from about 1361 to 1364 from minimum here to maximum there. That's a 12-year cycle, okay? And then there's variations to those cycles like grand solar minimums and then grand solar maximums, okay? Here's a Maunder minimum, the Sporer minimum, Wolf minimum, Oort minimum. We have the Dalton minimum at the beginning of the 18th century. We can actually see that one right there. A very weak grand solar minimum, but still classified by many people as one. But we see the Maunder minimum there. Our total solar radiance flatlined, our sunspots flatlined, though it still is at this base load value, right? The changes to that TSI is mostly in the extreme ultraviolet and the X-ray part of the light spectrum, as well as the radio frequency part of the light spectrum. The visible light, the infrared light, and the ultraviolet light typically doesn't change that much. It has the lowest variability going from solar min to solar max. But look at what happened after the Maunder minimum. This is, again, our constructed total solar radiance, but we could also look at this data with sunspots, and it'll show the same effect. We have been having 300 years of increasing light energy. So we see these cycles going like this. We do have that Dalton minimum there, but in general, it looks it's been going up, 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 up. This is the 1900s, like the 20th century right there. And then this is what we project, at least some scientists are projecting for the future as it relates to solar activity. They're expecting solar activity to get even more wild for the rest of the 21st century. So if that is the case, that is going to bring even more energy into the Earth energy system. And therefore, if there is any modification occurring on our planet, which there is, it's going to just amplify any of those effects and make everything more volatile. So that's the thing we also need to keep in mind. By perturbing this system, we're making it more volatile. Bigger floods when they happen, bigger droughts when they happen. Longer droughts, longer periods of intense rainfall. just everything's just going to be more volatile. That seems to be what occurs when the Earth undergoes an electrification process. That's what we're seeing right now on this planet. Next, let us talk about one of the main things that's causing the weather to change on this planet. And again, you are going to have to turn off, if you have this in your brain, hopefully you don't, but if you do, you're going to have to turn off that political programming that you may have in your brain, because we're just simply talking geology and geophysics here. This isn't talking about anything other than that. So we have hydrocarbon combustion, and basically hydrocarbons are these molecules that have carbon and hydrogen in various ratios. For example, methane is CH4, so it's 1 carbon atom for every 4 hydrogen atoms. And you have a hydrocarbon, if you give it a little bit of energy in the presence of oxygen, it undergoes an exothermic reaction and produces carbon dioxide, water, heat, and light. Now, these hydrocarbons, there's a whole bunch of them, of course. You know, there's like natural gas, there's oil, there's coal. That's not exactly, you know, it's similar, but methane, all these different hydrocarbons, they are basically, right, they are inert and stable forms of sunlight that was sequestered over millions of years. So you have the Earth living its life, spinning around for millions of years, and there are, you know, plants dying, being birthing, dying, just constantly in this cycle of life and death. And a lot of those plants, they fall down, they go into like swampy conditions, it's anaerobic, no oxygen, and they actually then eventually get sequestered and turn into hydrocarbon via the geologic process. So we have been taking millions of years of stored solar energy, which again, as I just laid out, is the main driver of the heat balance and climate on our planet. We've taken millions of years of that and lit it up in just 200 years. If you, let's say, go back to 1850. So in less than 200 years, we've released a ton of sequestered sunlight energy on our planet. So these hydrocarbons, when given enough energy to break their chemical bonds in the presence of oxygen, they undergo an exothermic reaction, meaning that they actually then produce their own energy to keep it self-sustaining. Endothermic means that like it takes energy and reaches a higher energy potential state. These reach a lower energy potential state, and that state includes carbon dioxide, water, heat, and light. Now, you'll get more water from a hydrocarbon combustion reaction than carbon dioxide. So I think it's for methane, again, CH4. I think you get 1 CO2 and 2 H2Os. Yeah, because you have a single carbon there, and you'll have 2 hydrogen or 2 water molecules that will give you 4 hydrogen atoms. So methane reaction, for example, again, CH4 plus unlimited oxygen, we'll say, will give you 1 carbon dioxide, 2 water molecules. Water is the main greenhouse gas. It's a more potent greenhouse gas than carbon dioxide. So we've been putting more water into the Earth system than there was before. We're also in an interglacial period, so the Earth naturally is hotter right now, and we've been having this 300 years of increasing light energy from the sun. And every degree C that you go up in temperature on the planet, you hold 7% more water in the atmosphere. So not only have we released a ton of greenhouse gases, water being the main greenhouse gas, but also, for example, carbon dioxide having some effects, though it's by far not the main thing driving climate change. It's just one small component of a much larger complex system. All that has contributed to what's happening on our planet geophysically. And let us not forget that you're just also creating a bunch of heat and releasing a bunch of light. Light is pure energy. Heat is energy. And so we've just been having a bunch of heat production on our planet due to hydrocarbon combustion. So this is every single power plant, effectively, every single car engine, any generator, anything like that that's using hydrocarbons is releasing heat energy that has to be radiated away from the planet for it to cool down. This is long wave infrared radiation. There is a heat imbalance right now with our planet where we're holding more of this long wave IR than we're releasing. one reason why the temperature on this planet's going up. And then you have things like how now we're having more water in the atmosphere, other gas concentrations are changing, CO2 is going up, ozone's going down. There's a whole bunch of these things I could go into. But just from the simple physics, we're burning a lot of hydrocarbons, creating a lot of heat, and not all that is radiating away. So it's not about cow farts or human burps or any of these stupid things that political people bring up to say that climate change is a myth or something. We are undeniably having an effect on our planet by doing this. And it's just what it is. And I'm not saying it's good or bad. I'm just saying we've been changing the climate on our planet as a result of this, releasing more heat into the environment. And also, because we've been having more heat and more water, the atmosphere can hold more water. That's kind of like one of the base things occurring right now leading to all this. Because when you have more water in the atmosphere, it can then absorb more energy. So what's another thing that's been happening? We have to talk about the electric susceptibility of water, okay? Because water has some very special properties as it relates to electromagnetic radiation. I've talked about this before. I'm going to keep talking about this on the channel. It's very important that people get educated on this. Here we see the dielectric constant of water going from 0.1 gigahertz up to 100 gigahertz, okay? So this is part of the light spectrum. This is actually the microwave part of light spectrum. So once you're in this zone there, that's actually the type of energy that your microwave oven, if you use one, is beaming your food with to heat it up. How does that work? The water molecules in your food actually absorb some portion of that energy, and some of that energy that they absorb goes into causing the water molecules to vibrate like this, which generates heat, which warms your food up. But there's a lot of other non-thermal effects as well. But we see that at about 1 gigahertz here, the electric susceptibility of water is the same as it is for all the frequencies lower than 1 gigahertz in general, okay? So for water right at 0 degrees Celsius, we see it's near 90. And then as the water temperature goes up, that electric susceptibility goes down. It does absorb more energy easily from these sort of electromagnetic waves at higher temperatures. But in general, it's all kind of in this band there. It's not easily absorbing these electromagnetic waves. Then once you get past 1 gigahertz, and you start, especially like at 10 gigahertz and beyond, look at how the electric susceptibility of water changes. Now all of a sudden, it's absorbing this energy rapidly. That's why your microwave oven works, because it's using these sort of frequencies. Well, guess what? We use these microwave radio frequencies not just in our microwave ovens anymore. We also use them with cellular networks and also with weather monitoring stations. There's a little bit of a quantum observer effect I'll talk about. But every single cell tower now that's emitting 5G is in this frequency band right there, which is absorbed by water to a much greater degree than before. And that is one reason why they need so many of these cell towers out there. It's simply a completely different equation. Here we have an example of 4G versus 5G. So we see that there's much higher frequency. They have to be interspersed more often because not only does a higher frequency wave attenuate out faster, it's getting absorbed into water much easier. And so we're literally radiating everything around us. It's not just the atmosphere which is carrying water, it's also our bodies, plants, all life on this planet is getting blasted by these radio frequency energies, especially in urban areas. But you know, they're doing their best to cover 5G across the entire planet. And so how do you think this is fueled, right? They're taking energy from the local power plant and converting it into electromagnetic radiation. So at the same time, we're burning a lot of hydrocarbons in general. You know, there is green energy production. We have solar, we have wind, we have nuclear, but in general, it's fairly low. It's like 20% for the United States, maybe like 30%. France is a lot higher with their nuclear. Bhutan is 100% hydroelectric. But in general, most countries are burning coal, natural gas, and oil. So we're taking that, doing these exothermic reactions, and then we're taking that energy that we do get and blasting it into the atmosphere via, for example, 5G. Not all of it, but a lot of it. And we need a ton of these towers because it doesn't travel that well, so it's getting absorbed into the water and more. That's a big thing that no one talks about with weather modification, because now you just have so much more energy in the atmosphere already. And you're changing the atmospheric conductivity and therefore altering that global electric circuit. So we're talking about weather modification. It's not just jets flying in the atmosphere and maybe injecting particles and stratospheric aerosol injection. We're going to talk about that. It's not just that though. That is just like one little thing. This is the real meat and potatoes of weather modification. And there is more. So let us also talk about how we actually track weather systems across time. Here's a graphic just basically showing the energy of these microwave beams that come off of these NEXRAD towers. So we have all these towers across the United States, also across like Europe and other places to track big weather systems. For example, not this one. Like, how do we get this graphic there, right? Well, we're using these weather radar towers to reflect off of these systems so we can image them and model them. And from a standpoint of tracking a storm and knowing where it's going and giving people a heads up, this technology is very useful. Now we also do have various cuts happening to the different weather tracking agencies in the United States, so we're getting less and less information out to the public as a result of that. But in general, these are helpful for tracking weather systems and hopefully giving people a heads up as to things like this thunderstorm cell hanging out over hill country, then causing an insanely devastating flash flood. But look at the frequency. 2.7 to 3 gigahertz. It's right in that electric susceptibility range. It's starting to, at least. And so a lot of this energy will go out and just radiate out to space, but some of it does hit cloud systems, and certain cloud systems will create what's known as an inversion and cause this energy to bounce back like this. And so you're microwaving the entire lower atmosphere when you do that with very high energy microwave beams in that range, that frequency range that's absorbed by water. Look at the power on this. It's 650 to 750 kilowatts. So these are very powerful installations. They're all across the US, and anyone that's studied into quantum physics, just in general, knows that if you observe something, you affect it. There's an observer effect. So the only way to not affect a system is effectively not to observe it. And so by having these systems here observing our weather, we are fundamentally also altering the weather that we are observing. And because this energy here gets absorbed so well in the water, and what is a thunderstorm other than ice crystals and water droplets, it is just going to cause them to get stronger and stronger and stronger. Now, some people are talking about, okay, they're steering these weather systems using these NEXRAD towers. I don't know about that. This is just like energy going out like this. I'm not sure that's possible, but certainly as it relates to this energy overall enhancing the strength of weather systems over time, just continuously adding energy into the system, that is undoubtedly the case. How significant is the effect? That is up for debate and for further research, but just based on fairly simple physics, it is undeniable that we are adding more energy into our atmospheric systems and therefore into our weather than we would have if we did not have these installations. So that is also weather modification. So that's why I'm saying, the truth of weather modification is not just what these conspiracy theories are. There's a lot to it. And let's go into another new factor that is affecting things that most people are unaware of, and that is the fact that we have a bunch of satellites in space now, creating significant geophysical disturbances. Here we have a map of Starlink satellites, which make up the majority of satellites in space. There's less than 15,000 satellites in space from all the different countries. But Starlink from SpaceX has done a fantastic job at putting up thousands of satellites. The total now that they've launched overall is more than 9,000, as we can see with this graph here. And there are currently about 6,700 in service, 1,200 are inactive, and about 11,000 1,141 have burned up, and that is what I want us to focus on. But before I cancel out the total line, remember that every single satellite that is in space eventually will burn up into the atmosphere. None of them are permanent. So every single one of these eventually will burn up. Question is when? Now, if we turn off this total line, check out what happens. The rate of these Starlink satellites burning up has gone up exponentially, specifically in 2025. So we were down here back at the middle of 2020, 0, okay? Because they just started launching these with the rollout of 5G in mind. So 5G rolled out in 2019, roughly, but it really took on in 2021, 2022. So this is like new to all of us, effectively. This is not like 20-year thing. You know, there have been other effects going further back, but really that exponential change is going from 2020 to now, okay? But then we see, you know, fairly, I guess, almost linear growth going all the way up to about the middle of 2024. Then we get a big increase right there going to December. And right in the middle of December 2024, we've basically doubled the amount of satellites that have burned up. And these satellites weigh, they're quite heavy. I think it's like 250 kilograms minimum for the first generation. The new ones are heavier. They're composed of mostly metal, and they go down, they'll blate into the atmosphere and effectively distribute a bunch of metallic dust across the entire globe because they're always coming down in different locations. Now, this has a lot of geophysical effects. This ablation of satellites has been shown to degrade ozone, and also if you have a metallic satellite coming down, it's going to create these conductive metallic particles. So, for example, aluminum will get, some of the aluminum will get ionized and become Al3+. And now you have this heavy metallic conductive ion, which can start to alter that conductivity profile of the atmosphere and the global electric circuit and drive stronger systems. It can also create stronger geomagnetic storms, which have an enhancing effect on tropospheric weather, especially where there are zones of already enhanced charge differential, like with a thunderstorm, a cyclone, tornado cell, something like that. So this is another thing that is modifying our weather. How, like, to what degree, how significant, that is up for further research and debate, but it is undeniable that this is also modifying our weather. And these metallic oxides are one of the main things that are known to reflect sunlight as well. So that is where stratospheric aerosol injection comes in, because there's a lot of research proposals out there, and perhaps already some covert operations that, you know, I don't know if that's the case or not. I just know that there's people that have looked into it. I haven't found a good consensus on that, but there seems to be something funny happening as it relates to that, but I can't give you a definitive statement. That'd be irresponsible of me to do so, and actually of anyone to do so. You just have to do your own research and wade through the muck of conspiracy theories, basically. It's just what it is. But one of the main things that they want to use for the stratospheric aerosol injection are metallic oxides. Well, we're already getting these metallic oxides to rain down into our planet as a result of all these satellites. And they want to have, like, not just 9,000 satellites, they want to have like 40,000 for Starlink or more. And then China wants a mega constellation or 5. And then there's also other mega constellations being planned in the United States and in Europe. And so soon, if they get their way, there are going to be hundreds of thousands of satellites, and you're going to have probably 100+ satellites burning up every single day. It's already getting close to like 5 satellites a day are burning up as a result of Starlink. I mean, again, if we go here, we can get that exact number, or as close to exact as we can get. Here we have June 30th, 1138, and then 1132 on June 26th. So it's like 2 to 3, and sometimes it's more per day. It's really very quite significant. Let us talk about stratospheric aerosol injection, because that is a significant thing that people have been testing. It's not like it's never happened before on our planet, but how widespread is that? That's a completely different story. I don't have the answer, again, as I've said. But The idea is that if you take reflective aerosols and you inject them up to the stratosphere, which is you have the troposphere and then you have the stratosphere. So it's the part of the atmosphere above where planes fly, especially like 35,000 feet up or so and higher. Eventually you go to different parts of the atmosphere, but the stratosphere is where planes fly. And it doesn't have the same convection as the troposphere, the lower atmosphere. And so if you inject aerosols up there, the idea is that they'll stay up there for a while and reflect sunlight. And the idea really came about by noticing what happens when a volcano explodes and launches a bunch of aerosols up into the stratosphere, because a really powerful volcanic eruption will have its ash plume actually reach the stratosphere. It has a lot of sulfur compounds. Those are like sulfur dioxide is reflective. It reflects sunlight away and you get a global cooling effect. And so you can have these aerosols be either like fine grained solid particles or even like liquid droplets. And the main things that are being used and or are being researched to be used is sulfur compounds or metal oxides. And what the weather modification experiments that they're often doing now, like as reported by that weather modification project page, which is available to anyone to see. Again, this guy right here, just scrolling through these, a lot of them are of like silver iodide. But the stratospheric aerosol injection, how widespread is that? Is it global? Is it not? Is it small scale testing? They do it in Dubai. They're already doing it in the Gulf states to help bring in more rain because it's so dry, dusty, and hot there. So like there's undoubtedly already government-led programs using that technology at play, active on the planet. But as it relates to, is every single passenger jet in the plane spraying these things for a covert operation? That's, again, you're just going to have to do your own research. I don't think that's the case. You know, passenger jets, no, I don't think that's the case. But there's just so much conflicting information out there. Some people are saying these aerosols, like the liquid metal particles, like these tiny little metal particles are being put into jet fuel itself. So you don't need to hide the tanks or anything. It's all discrete because it's in the jet fuel itself. Other people are saying that it's specific planes that are flying continuously that do it, and jet planes are not at all part of the equation. There's just so much conflicting information out there again. So I'm sorry that I have been unable to get a better read on the situation. And I'm a good researcher and I wade through the junk really quite easily. And it's just so much junk with the weather modification stuff. So I've been talking about this before, but it's one reason why I haven't gone super in depth, because it's just really difficult to find out what the truth is. But we do know the truth of how our radio frequency technology is altering the overall energy budget in heat and conductivity of the atmosphere. And we know how use of hydrocarbons affects that, and the Starlink effect now, all these things. So this information is out there. There are other things too. For example, you do have these auroral ionospheric heaters, which can eject energy up to the ionosphere and create these magnetic ducts that allow particles to rain down. That's called HAARP. Or at least there's one of the installations is called HAARP, H-A-A-R-P. That's another one of these things that a lot of people talk about. They often don't know really what they're talking about, but they still do. But there are other ionospheric heater programs out there that affects the geophysics of the planet. So there's a whole bunch of things which fundamentally, at the end of the day, modify our weather and are a deviation away from the natural system. If we weren't doing these things, like let's say we went back 2,000 years ago, okay? The main way we would be modifying the weather 2,000 years ago is with the fires that we were burning and the soot that was going up, and that'd be a fairly minor effect. Same with like during the Neolithic period, or even going up to pre-industrial revolution, our effect on weather and the climate was effectively zero. But now, because of all these factors, we are becoming a more important modifying factor on our weather and climate, of which the sun is the main driver of activity. So that is the science there. That is the report for you. Really unfortunate situation in Texas with this flash flooding. There have been massive floods also in China. We've been seeing huge floods in like Paris and Spain recently. All across the world, we're seeing this big kind of volatility in terms of massive deluges of water. Then other times you get big droughts, but in general, we're seeing a lot of activity like this. Just Earth electrification is going to affect more than just our weather. That's the thing. As the Earth becomes more of a storm world, like Jupiter, if we really zoom out to like the planetary solar system scale, the Earth is becoming a storm world similar to Jupiter. Our storms are getting stronger. The global electric circuit's getting stronger. These super bolts are becoming more frequent and deadly. All these things are pushing us towards a more stormy planet, and the result is going to be things like this that occur, which is it's just what it is. It's highly, prayers for everyone affected in Texas, but this isn't going to stop tomorrow or today. Like there's a lot of inertia to this. So unless some big volcanic eruption goes off and gives the Earth a big dose of cooling, or we have some crazy third outside influence that come in to change the planet perhaps in some significant way, there's a lot of inertia with this, with our climate systems, you could say. I will keep at it, and to give you my best understanding, perspective as to what is happening. I am a single human being, so I am not perfect. Please make sure you seek out other perspectives and also do your own research. But I do my best to make this as comprehensive and holistic as possible by being interdisciplinary and really researching pretty deeply into these different fields and finding those cross connections, which is why I'm able to see sort of this bigger picture, and it's not that much of a headache to do so. Whereas a lot of other people, you just move one field of science over from them and they know nothing, and they just completely say, oh, that's not true or whatever. So we do everything possible here as a community to research and everything with an open mind. If you like the sound of that, then please subscribe. Again, I've been your host, Stefan Burns. Please take care of yourselves. Sending prayers to everyone that has been affected by this flash flood in Texas, and rest in peace for everyone that has lost their lives in this tragic event. Weather modification is now entering more into the public consciousness, but please keep in mind that as it becomes a talking point, they are not going to tell you what the real situation is, the truth of it. This has been going on for a very long time, and each and every single one of us has been contributing through it just because of normal human society. That is what we've been doing at a societal scale, has been modifying the weather. So that's the truth of it. Solar activity, though, is the biggest component I tracked on the channel. So if you'd like to stay up to date, then I hope to see you around. Again, wishing you all well. Take care. I'll see you all in the next video.